start the recording. The class starts with significant delay on 19 February 2025. Yeah, great. So, requirements. This is the third lecture. This is the last time when I tell you you have to write 2 tests and you have to pass. For pass, the passing score is 41% of both tests. If you fail, you have to correct the test. I gave you free time for writing the test and retake the test. And both tests are 25% in the grade, and half of the grade will come from a written exam. There are some bibliography. Well, officially, during this semester, I will give you a new syllabus. This is one of my duty, and also new bibliography, and which is very weird that the Hungarian class and you have very different syllabus. So, but they will follow your schedule, because I will not prepare for 2 different materials. Okay, this is repeat, and we can go through quite quickly. You remember math? Yes?
Will you be giving us demo versions for the midterms like last semester?
Yes.
Thank you. Yeah, I will. The question is when. Wait, this is. I should. Just a moment. This is 19th of February.
Mm-hmm.
Next time 60 of.
26?
And then it's.
Then second.
Second?
Oh no,
No.
fifth.
Fifth.
Yeah.
So it means we have today and 2 other class. Well, I will give you something, but first I have to figure out what to ask from you, because this was repeat, most of them. Actually, there was only a really few stuff. Perhaps some projection, transformation. There will be a special thing next time. Yes, I will, but that will be, I think, the last time, the very last time before the test. Okay? You will have 1 week to fix it, to solve the exercises.
Will you give it with the answers right away? Or?
No, the exercises. I mean, I give you a task, a sheet with exercises to practice.
But then we will not know if we've done that practice exercises correctly.
Oh, okay, let's see then the calendar. Yeah.
Maybe you can just explain how the answer should be given. That way we can understand.
Yeah, like you give like a file with exercises and the file with answers. So we do the exercises and we compare them to the answers.
Oh,
Something like
wait, something interesting is going here. Just a moment. I have no internet, and makes difficulties. What's this? So we are here. Next time we will be there. Next time. This week, this first week of March, I will give you something, and at least I will give you the solution. Is it okay? Then you know, the difficulty is that this is my first time when I give this class, this lecture. And it means I am figuring out before class what to tell you. And the hardest part is, this exercises. Are these exercises. Okay, so it will be done. Okay, let's start the let's only repeat. So if you have a square matrix, you can calculate the determinant, and the determinant is a very useful thing. Okay, this was just the definition of matrices. And yeah. Okay. This is the way how you calculate, this is the definition and the way how you calculate a matrix. So what does it mean? You have a square matrix and you go through all, sorry. Sorry. Okay. This is so there. Okay, so this determinant is a special number, and there are different ways how to calculate it. If you have a matrix, then the simplest way, actually not the simplest way, but the most general way to calculate it, that you have the matrix, and then determines sub-matrices, determinants actually. Take a row, be careful, take a row, any row or column, and you start. Here I started with the alpha 1, 1, and then I delete its row and its column and row, and I have a subdeterminant. In the definition, there was this sign stuff, and it means on the different place where you do this Laplace expansion, then you have to change the sign. So the second column, first row, the sign is minus. Then you delete the column and the row, and you have subdeterminant, and then also you have the same. Then the next row you would do the same, but there are no determinant, just scalars. So this 2 times 2 determinant became this alpha 2, 2, alpha 3, 3, minus and alpha 2, 3, alpha 3, 2. And then do the same for this. I will give you an example. And you were, I don't know, but you were the best, one of the best of your class. This is a good method if you have a big matrix, larger than 2 times 2, 3 times 2. If you have 4 times 2, 5 times 2, 100 times 100 times, then you can use this. Well, I would be see how you calculate 1 times the size square determinant. Then you can use it. But when you have a smaller matrix like this 3 times 3, then you can use another method, this Saurus rules. And if you use this method and you reach the range of 3 times 3 determinant, then you can also apply the Saurus rules. Then, important, you can choose any row and any column to calculate. What does it mean? You have this determinant. How do you start the calculation?
You can choose the second row.
The second row, yes. You can use brute force and choose the first row, but it's not necessary. So if you do, then everything is 0. I can write this down, but I think you understand. So it's minus what's this? Minus 1, 2, 3, yes, and then 1, 1, 2, 2, and 3.
Why minus if
Sorry?
why minus if according to chessboard?
Oh, sorry, because I'm tired. It's plus, because it's plus here. So this is the 1, 1, and minus on 2, so it's minus 1 on 2, it's 1. Thank you. Okay, so you can continue this with then now actually you do not need to continue this. I will feel no, it's better. This is 0 because two columns, actually 3 columns are the same. Then it's 0. but I will continue this because now it's minus. Okay, that's simple. Here, I use more or less brute force, but actually I should not calculate this because this column, this column, this column are the same, so that's 0. This is a rule that I will tell you because there are different methods to calculate the determinant, and it's an advanced rule. This is just the Laplace or cofactor expansion. Do you remember?
Yes.
You remember?
Doing
Okay.
the example helped.
Okay. Sorry?
Doing the example helped remember.
Okay.
Yes.
Okay, so you remember, then perhaps it's useful to repeat this. Actually, when you are in the test, then you do not need to do anything because that's 0. Actually, that's just an example. Okay, next. This is the Saros rule, or Saros rules, or doesn't matter, for these matrices. 2 times 2 or 3 times 3. That's very simple case. What does it mean? You calculate this, and then you subtract this. For 3 times 3 matrices, you start with this. It's 1 times 1 times 1 plus continue this. Continue this. And then finally, sorry. Okay, so what I have done, exactly the same. For 3 to 3 matrices, I start with the mean diagonal. I calculate the product. Then I go to the next. How can I say this? It's not row, so it's something parallel than diagonal. So the next, I start the main diagonal, then I jump to the next row, and then continue here, calculate the next one. Go here, and multiply this, and this, like here it is written. That's okay. Next term, this is minor diagonal, like this in Hungary, in Hungarian we call this. Calculate this, but this sign is minus. Then jump 1 row, and then again. So this simplify this stuff because you need less calculation, less operation than with the cofactor or Laplace expansion. So what is this? This 1 plus okay, so this is 25, 21, 17, and then 8. I am right?
Yes.
Okay, great. So this is it. This is familiar from last time. And why can we do this? Interesting. Actually, if you do the Laplace or cofactor expansion, you got this Sarus rule for the 3 times 3 square matrices or determinants. Actually, determinants are always square, otherwise you cannot calculate. And also for the 2 times 2, which is easier. You do not need to write so much the subdeterminants and everything. Just go through this way and then this way, and then you have the result. And also there are other things that helps you to fix things. Okay, that's interesting. When I talked about the vectorial product, I gave you the definition how to calculate the vectors, and this is one way. One way to calculate the vectorial product of 2 vectors. Well, it seems I don't spare this place on the tables. Last semester it was very good. I have many tables. Always. 3, 6, whatever I wanted. Now I have only 2 or sometimes only 1. Great. I don't know why I cleared the board. Everything is written here, so the okay. So that on the top is the coordinates of the vectorial product or cross product given by representation, Actually, this is a way how to give this. You can write the unity vectors a1, 2, 3 in this way, and the other vectors a and b, and when you calculate the determinant, you got the same that is there. It's weird. Okay, this is a repeat, but something is bad because I miss the deduction. But if you do the deduction, it's quite simple. If you start from one side, you got the other. Doesn't matter. Triple product, that was A cross B, that's a cross product, and then the result is multiplied scalarly with C. You can write this in this form of determinants. Last semester there was many statements, theses, that allowed us to write vectors to matrices and determinants and somehow divide matrices to vectors, or we just said function is a transformation, or a transformation, linear transformation is a matrix. In the real life, without any restriction, you just change the vectors, the two arrays, the matrices, but there is a mathematical background for this. But this is the applied linear algebra, so you do not need to deal with this. Yes, and you remember if you have three vectors and you do the triple product, then that's the volume of the parallelepipedon. Or if you construct this determinant, then also you get the volume of the parallelepipedon. You also can check the linear independence of three vectors. Okay. These are interesting. Let's jump to the second element of this row. Of this list. If two rows or columns of the matrix are the same, its determinant is 0. This is what I did just a few minutes ago. Okay. These are statements, so it should be proved. If you change two rows, then the value of the determinants, or two columns, if you change two rows or two columns, then the value of the determinants change the sign. Fortunately, last semester, from 190 students, only a few, less than 20, had to take an exam, and one of the theoretical question was this. I gave something big determinant, them, I don't know, it's it was actually bigger, so you cannot see, because I cannot see either, doesn't matter. We have this one. Ow, ow. Doesn't matter if it's 1, 2, 2, 2, 3, so this is 0. It's not visible. Why? This is a chalk. change for the all determinant times the scalar. And you also can somehow dissolve the matrix. There will be example for this in this semester. Okay, if you add a row or column to a matrix, to another row multiplied by a constant number, a scalar, then the new matrix will be the same of the determinant of the original matrix. It's very weird. Last night I looked for this some material for a very long time, and it seems to be somehow I messed up things. I don't know how, why. Okay, you have learned, I have mentioned the Saros rules, the cofactor or Laplace expansion. Somehow I repeat this, I don't know why. But there is another method, the Gaussian elimination. You have to change the operation, which is allowed by these rules, the value of and the appearance of the matrix for a so-called upper triangular matrix. It's not a magic. That's just in this form. And this is now better. And that is a thesis, and you can easily understand this, that the determinant of this is the product of the main diagonal, so that's 1. Everything is 0. So if you apply the Sar's rules, then this will remain, and this will be 0, this will be 0, this will be 0, this will be 0, and also this will be 0. So that's why you do this transformation, and the transformation says the following. So this is the upper triangular matrix. And okay, you try to transform the matrix, the determinant, to this form, because there is a statement that the value is the product of the elements in the main diagonal. So what you should do, you can change rows. You can multiply rows with a scalar, which is not 0, and you can add the rows to each other. And let me see. The disadvantage of this method that it's easy to make a mistake. So please, because I need a bit more caffeine that I had today, I might do a mistake, so please listen. This is the this is the 21 exercise. And the B. I should start with something smaller, but then it's not easy to understand the point. That's plus. The point of this. Okay. Is it okay? Okay. Okay. So, first, you are in trouble because that's 0. So let's change the rows. It is allowed. Okay, I want to eliminate this one, so I will subtract the first row from this row. So it means nothing changed here. Here, nothing changed. But here, that's 0. That's plus 2. And then that's minus 1. Okay, that's ready. Then I want to eliminate this. Oh no, yes. I want to eliminate this row, and I multiply with half the second row. Actually, you can do it in one step later. Then I add the second row to the third row. Oh, it's not equal, it's just an arrow. Nothing changed here, nothing changed here, nothing changed here, nothing changed here, nothing changed here. Okay, but here does not change. Here that's 0, and then that's 2. So the result is minus 4, because this is an upper triangular shape. Okay, let's check it. That's 0. I just check with the Cyrus rules. That's 0. That's minus 12. 6, that's 0. Okay? 6 minus, so this is minus 12. This is 8. I am minus 8. Yes, I wrote minus 8. Wait, is it minus 8?
It's minus 8.
Minus 8, then it's plus 8, thank you. Bum, 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 bum.
That's 0.
Yeah, the other one is 0.
Yeah, so it's 8.
So it's 8.
Something is wrong then.
Maybe we haven't multiplied the result with the coefficient that we multiplied with.
Yeah, we halved one of the rows.
Yeah, we have one of the rows.
So we should multiply. We divided a row.
Yes, you are right.
And
But
we
why it is not written here? Wait.
And also the sign is changed because the rows are changed. We changed the rows once. Yeah.
Yes, you are right. You are right. Everything. You change the rows, so it means that's minus. And also
The 1/2. 1/2 of row 2.
here, when I did it, I should something is odd. should have note these operations. Okay. Class dismissed. So this is over. Thank you for your attention. And we are actually at the end of the end of the class. Thank you.